Hey everyone, welcome. Today, we are jumping into a really cool and powerful math skill, how to turn real-world problems into equations and inequalities. And this gets really interesting, especially when you've got stuff happening on both sides of the equation. This is how we model and solve some pretty fascinating challenges.
Okay, so let's kick things off with a pretty cool puzzle about two growing snakes. Now you're going to want to pay close attention here, because this isn't just some random example, it's actually the very first question on your assignment for this lesson. So yeah, we're going to get a head start on it together right now.
So, here's the game plan for today. We're going to start with understanding the puzzle, then figure out how to translate words into math, and then build our own equations. After that, we'll see what happens when things aren't equal, and then we'll wrap up by tackling that first assignment problem together, step by step. So what's the big idea here? Well, it's actually pretty simple, but super powerful. We want to take real-life situations, just like our snake problem, and turn them into a mathematical model. You know, an equation or an inequality, so we can figure out that one missing piece of the puzzle and get a perfect answer. Okay, so how do we actually build these things? Well, we're going to start with something you already know pretty well, equations. But we are about to seriously level up from the simple stuff you've seen before to something way more dynamic. So, over on the left, you've got something you've probably seen a bunch of times, right? A simple two-step equation. One expression with a variable, and it equals a plain old number. But now check out the right side. This is the new stuff. We've got variables on both sides of that equal sign. You can think of it like two different situations, two moving parts, and we're trying to find the exact point where they totally balance out. All right, here's the secret sauce to all of this. You have to be a good detective. You have to learn how to translate regular English words into math operations. But don't worry, you don't have to guess. I've got a cheat sheet for you. Okay, this chart is super helpful, but let me point out the most important clue on here. Look at those words under multiply. See every, each, and per? When you see one of those words in a word problem, a little light bulb should go off in your head like, aha, that's the number that gets multiplied by my variable. It's a huge giveaway. All right, enough with the theory. Let's put our new detective skills to the test. We're going to use those keyword clues to build an equation from the ground up, using this great example about two bank accounts from your lesson. So here's the situation. We've got two people, Jakob and Bedelia, and they're both saving money. But they start with different amounts, and they're saving at different speeds. And our job is to figure out at what exact point in time will they have the same amount of money. So we can totally break this down. It's just 4 simple steps. First, we write a little math phrase, an expression for Jakob's account. That's his starting $500 plus $25 per week. Then we do the same thing for Bedelia, her $100 to start plus $50 each week. Since we want to know when they're equal, we literally just set those two expressions equal to each other, and that gives us our final equation. And bam! There it is, our final equation. You see, on the left side, that's Jakob's total savings. On the right side, that's Bedelia's. That little equal sign right in the middle, that's the sweet spot, the exact moment we're looking for where everything is perfectly balanced. Okay, so we've totally mastered finding the exact moment when two things are equal. But what if we want to know something else? What if we don't care when they're the same, but we want to know when one thing is more than the other, or less than the other? Well, that's where inequalities come into play.
And guess what? The process is almost exactly the same. We still build our two expressions for each side. The only thing that changes is we swap out that equal sign for one of these symbols you see here. The trick is just to look for those key phrases in the problem, like is at least, or is more than.
So get this, and this is the key takeaway. We build the expressions for the two companies in the exact same way we did for the bank accounts. But because the question asks when one is more than the other, we just pop out the equal sign and drop in a greater than symbol instead. That's it, just a simple swap.
All right, team, let's get you rolling on that assignment. We're going to go all the way back to our snake problem from the beginning, and I'm going to walk you through exactly what your worksheet is asking for in each of those lettered steps.
So here's the full problem, word for word from your worksheet. We're going to unpack steps A through E together. And honestly, once you see how this is done, the rest of the questions are going to feel like a breeze. Okay, part A. Seriously, don't overthink this one. It's just asking you to find the question in the problem and write it down. What are we actually trying to find out? Easy enough. Next up, part B, general form. Now,
I know that sounds super technical and maybe a little scary, but it's not, I promise. It just wants you to write a simple sentence in words that shows what you're setting equal to each other before you even think about the numbers.
Okay, now for C and D, this is where we build our two little math phrases, our expressions. For C, the left side, we'll write 1 for the anaconda. Its starting length of 5.23 plus its growth of 1.27 times per month. For D, the right side, we do the same for the python. Its starting length of 4.76 plus its growth of 2.04 times per month. And finally, part E is the grand finale. You just put all the pieces together. You take the expression from C, the equal sign idea from B, and the expression from D, and you smash them all together to make the final algebraic equation that you're going to solve. Okay, before I set you loose on the rest of the problems, let's just quickly go over the logistics. The assignment is a PDF, and you'll find it attached at the very bottom of the lesson. You've got options. You can open it up and write directly on it using your Chromebook tools, or if you prefer, just write your work out on regular notebook paper. And here's a huge time saver. You do not need to write out the full questions. Just your work and your answers are fine. Then when you're all done, just upload it for your teacher. So there you have it. You now have this incredible tool to model any situation where two things are kind of racing each other, changing over time until they hit that one point of being equal. It could be two cell phone plans, two people saving money, anything. So my question for you is, what else in your world is like this? What other race to equality can you think of that you can now model with an equation?